So you've just seen the math for diffraction through a single slit, and now I want to show that to you with this demonstration. So in the previous video, we had that red laser passing through a pair of slits. Now we have the same red laser passing through a single slit. At this point, that single slit is actually very, very, very wide, much wider than the wavelength of red light. So all we see is a red dot on the screen. This is basically just like shining a laser beam on this screen, nothing more, nothing less. But Caleb from our technical services group is standing over there by the slit, and this slit has the nice feature that he can adjust its width. So why don't you start making that slit narrower, Caleb? As he makes that slit narrower, watch what happens to the red spot. Still looks like a red spot. And now you start seeing something growing to the right and left of it. And why don't you stop there for just a second. At this point, the slit is getting narrower. We're going to make it narrower still in a second. And what you see is this pattern, this diffraction pattern of bright and dark spots to the left of the central very bright spot. But let's make it narrower still. Narrower, 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 narrower. Yeah, that's good. Let's stop there. Maybe even want a little narrower. Good. Let's stop there. So now we see the classic single slit diffraction pattern that you just learned how to describe in equations with a central bright spot. And if I measure distance from the middle of the bright spot, when I go L lambda over A to the right, I get to a dark spot. Another L lambda over A to the right, I get to the second dark spot. Another L lambda over A to the right, I get to the third dark spot. So let's make the slit a little narrower still. And you see that when Caleb makes the slit narrower, the pattern stretches out. So he's making A smaller, and the spacing in the pattern is L lambda over A. So when he makes A smaller, the pattern stretches out. Let's make the slit wider again. When he makes A bigger, the pattern contracts. The pattern scrunches together. Let's make the slit wider. And as he keeps making it wider, as he makes the slit wider, you see the pattern is contracting, 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 contracting. If we stop there, this is about where I showed it to you the first time. Right now we have a relatively wide slit, and so the spacing between dark spots in the diffraction pattern is, the dark spots are quite close together. And this illustrates a very, very generic feature of interference of waves. I should say, by the way, that what we're seeing here is referred to as diffraction through a single slit. But remember that the way you think about this is it's the interference between the waves that are going through all the different little spots along the slit. You think of taking that slit and dividing that single opening into lots of little bits. And then you think of the diffraction between the waves that go through different points on the slit. So we tend to refer to this as diffraction, but this could just as well be called interference, because this is the interference of the waves that come through different points on a single slit, which we call single slit diffraction. And what you see here is a very generic feature of all wave interference phenomena, which is that as the structure through which your waves are passing, as the structure gets smaller, the interference pattern on the screen gets bigger. Because the spacing, in this case, the spacing between dark spots is going like L times lambda over A. As A gets smaller, the spacing on the screen stretches out. When A is bigger, the spacing on the screen gets closer together. So let's make A smaller again so you can see the pattern again. So let's make the spacing smaller, and you see the pattern stretches out. And stop there. And so here again, you can see, at this point, you can see the classic single slit diffraction pattern that we did in the previous videos that we did the math for, with a spacing around the central bright spot between this minimum and that minimum of 2 times L lambda over A, and then the spacing between subsequent minima of 1 times L lambda over A, all of which we saw in equations. So what we're going to do next is we're going to put single slit diffraction and interference between 2 slits. We're going to put them together. And the way we're going to do that is I'm going to ask Caleb to switch the single slit for to replace it with the double slit that we used before. And I'm going to come back to the pattern that we saw in the previous video and discuss it further. So could you switch that slit? So actually, before we look at the double slit again, I asked Caleb to turn the lights off so we could see the single slit pattern in the dark. And like we did last time, I'm starting with a very, very wide single slit. So the laser is just shining through the single slit without anything happening. And yet we see all this structure around the bright spot, which I didn't remark on before. This structure, these faint modulation, sort of mottled pattern around the bright spot is actually from diffraction also, but it has nothing to do with the slit. This is the diffraction of the laser light, the edges of the beam, as it comes out through the oculus on the front end of the laser. So if we started trying to analyze this mottled pattern quantitatively, we would actually be studying the structure of the oculus on the front end of the laser, which we're not going to do. Caleb, like we did last time, could you make the slit narrower so we can start seeing the single slit diffraction pattern? So as the slit gets narrower, you start to see the red spot growing fringes to the right and to the left of it, because it's shining through a vertical slit. And we'll stop there. As we saw before, once the slit is narrow enough, we see a classic single slit diffraction pattern with a wide bright spot separated between two dark spots. And the first dark spot, the dark spot on the left and the dark spot on the right are 2 times L lambda over A apart. And then as I go further, I find another dark spot, and the separation between dark spots on the right or on the left is 1 times L lambda over A, just as we saw in the math. And let me ask you, Caleb, to make the slit narrower and narrower and narrower. As the slit gets narrower, the diffraction pattern stretches out because the scale of the pattern goes like 1 over the slit size. And so here it's very, very stretched out because the slit is very, very narrow. And now let's make it wider again. And we'll see the pattern coming back and shrinking down as the slit itself gets wider. So by studying the pattern, I learned the structure of the slit.